Welcome to Meliora's channel, your go-to place for C# and data analysis tutorials, products hands-on demos, and insider secrets to keep you at the cutting edge of innovation. Our goal is to break down complex tech topics to a level that you will easily understand to supercharge your skills. Without further ado, let's jump right. Hello, ladies and gentlemen. You're welcome back to Meliora's channel. In today's video, we are going to discuss a very interesting topic in C# programming, and that is Lambda Expressions. We would kick off this discussion by basically starting with a definition. So what is Lambda Expression? A Lambda expression in C# is a concise way to define an anonymous function. And what is an anonymous function? It is a method without a name. And that definition is done by using the syntax, the maps to syntax. So an anonymous function, there are a couple of things that are mandatory to see in line with this definition. You need to see a definition of an anonymous function, which is a function without a name. And then also you need to see the use of maps to symbol or maps to syntax in the process of that definition, in the process of doing that definition. In that definition, you need to see that maps to syntax. This part of the definition, I think we would keep for now. It is enough to stop here at this very moment. And as we progress, we'll come back here to then clarify this. I don't want us to start looking into this and start being confused right from the beginning. So the definition as it is up to this point is enough for us to progress at this stage. So in summary, it is a concise way to define an anonymous function, which is a method without a name, using the maps to syntax. And that is all you need to know about Lambda expression in terms of its definition. What is it? So now moving forward, so what is the structure of Lambda expression? Now that we know the definition, what is the structure of a Lambda expression? So the structure is usually centered around this maps to symbol. So on the left of the maps to symbol is usually a set of parameters within the parentheses. So you have this parenthesis and then a set of parameters within it. And then on the right of it, you have an expression or a block of statements, representing a list of expressions. So when you have a set of parameters as shown in this example, A, B, and then the maps to symbol, and then an expression in this, as shown in this particular case, A plus B, then that is a Lambda expression. And according to this definition, what this Lambda expression has done is to define an anonymous function. So which is a method, you've defined a method, but just that method does not have a name. But that's what this syntax, this statement has done, essentially. And we will get to understand this as we get hands-on into it. So again, moving forward, even though this is the structure of Lambda expression, you would find that in actual programs, the structure will always be such that you are assigning this Lambda expression to a delegate variable. And therefore, what you see most of the time in programs will be delegate variable equals to then the Lambda expression, which is parameters on the left and then expression or statement block on the right. So if you then looked at this example for a more complete statement than the example we showed here, So it will then be that you have a delegate, a func delegate, which is a built-in delegate. And that func delegate, you are now defining a variable of its type. So a variable add of type func delegate or of type delegate for simplicity's sake. And then you are assigning this lambda expression, which is an anonymous, which defines an anonymous method or anonymous function. And that anonymous function is taking two parameters, A and B, mapping those two parameters to an expression that sums up the two parameters, A plus B. And this A plus B will be returned as the result of this whole method, this whole anonymous function. So for this to work, signature matching is a very big topic in the delegates world. So this delegate here defines a function that has three parameters, that takes in three parameters. The first two are input parameters and they are of type int, and the last one is a result parameter and is also of type int. And for you to define, if you define a variable of this type, for you to assign anything to this variable, that thing must have the same signature as this, which means it must have two input parameters that are of type int and one output or result parameter that is also of type int. If you look at this method, this anonymous method or anonymous function we've defined, it's got two input parameters A and B, and it will inherit those input parameters. It will look at this as long as they are int, and then on the right hand side it then has an expression which evaluates to summation of these two int values. So if the summation of these two int values will also result in an int. So as long as this outcome results into an int, then it matches the signature of this function, this func delegate, and therefore this line will execute without issues. So it's important to also mention that this could have been a named method. In this particular example, it is an anonymous function, an anonymous method, but it could have also been a named method, in which case the name of that method is what will be here and not the lambda expression for an unnamed method. So so if you were to have a function, a proper function or a proper method that you put in here, you just put in the name of that method and that's it. But that is now not the lambda. So the lambda comes in when you want to actually create a function or what looks like a method, that performs the same job as a named method would have done, but you just don't want it to be a formal method because it's not something you want to be called from different parts of the program at different times. So it is more of an inline kind of expression of methods. So you, you take the logic behind the body of a method and you implement it as an inline sort of statement that executes at that very point where it is in the program. So, and a lambda expression it helps you to do that effectively because it just it inserts a block of statements that will look like a method, but they will not have a name. And that's what happens here. So this declares a variable add, which is of type delegate, and assigns the anonymous method represented by the lambda expression A, comma B in parentheses on the left, mapping to A plus B, which is the expression on the right. So, and that's brings us to a point where we probably can just go through this last part of the definition. It can take input. So now a lambda expression can take input parameters and return a value. And it is often used with delegates, like I said. So like function, action, predicate. These are the three most important inbuilt delegates within C#. And we are going to look at it as we progress in this particular video. So the key is what I've been explaining here, that a lot of times the lambda expression is not used on its own. It is used in conjunction or in the context of a delegate. So it's usually used and assigned as a way of assigning an anonymous method to a delegate variable. And that's why this second part of it comes up. But like I said, don't worry, if it's looking a bit confusing now, don't worry, it will all get clear as we progress in this particular video. That's our work. Our work is to break down complex tech topics and break it down in such a way that it becomes a lot easier for people to understand. So, but as we work towards achieving that, I urge you, if you have not done so already, to just please subscribe if you've not subscribed. If you have, just like, comment, just share this video to friends. Just show us love by doing that. And doing that would help the algorithm to discover and share this video widely to a lot of other people who may be interested in learning or understanding this topic the way you are doing now. So please just do that if you haven't done that already. Thank you very much. So let's return to the subject. So now I will move on to explain what a delegate is, because as you can see, for us to really do justice into the discussion of lambda expressions, there's no way you can avoid delegate, because even the scratching of the surface that we have done clearly has shown that lambda expression appears to be built on top of the delegate. So let's move, and then I will show what a delegate is, and then we would probably try to move on from there. So what is a delegate in C#? So a delegate is a type that can hold a reference to methods with a specific signature. So again, like we discussed earlier, so a delegate is defined as a type. You know, up to this point in our programming work, you would probably have seen that we use variables a lot. But we use variables for different data types up to this moment. So we use variables to represent integer, string, and things like that. So you have, say, a variable name, and then that variable name is of type string. A variable name, and that variable name is of type int. A variable name, and that variable name is of type double. So, but delegate provides us a way of defining a variable of type delegate. And what that means is that that variable can now hold methods or functions. So the other variables usually hold data of specific type. But with delegate concept, you can now create variables that hold functions or methods and not data, as we know up to this moment. So, which is impressive. So if you look at this statement here, which is the way we define a delegate. So it says public delegate int, math operator, int x, int y. So this, in this particular delegates definition or declaration, this definition, then this is a delegate named math operator. And this delegate takes two input parameters, x and y, and both of them are of type integer. And it returns an integer as the output or result. So what then happens is that down the line in the program, if you can define a variable of this type, delegate, and within that you can use that, you can assign any method or any function to that variable, as long as that function you are assigning or method you are assigning to that variable matches this signature, which is that it's got two input parameters that are of type int, and it's got the return type also as int. Once it has these properties, then that particular function or method can actually be assigned to this. So it's as simple as that. And then you can now swap out or swap in methods using this delegate variable at will at different points in the program. So it's such an interesting feature, really. So as we saw in that definition, there are three key inbuilt delegates that will be of interest for us. The first one is func delegate, and that func delegate is used when you need to return a value. So the syntax of the func delegate is T1, T2, T3. That's func, and then the input parameters, and the last parameter is usually the result parameter. It can take up to, I think, 16 parameters, but if it's exhausts the 16 parameters, then the first 15 will be input parameters, and that 16th parameter will be a result parameter. But if you are just using 3 parameters, for instance, then it means the first 2 will be input parameters and the third one will be the result. So however number of parameters you're using, what is important to note is that the syntax is that the last parameter specified is the result parameter, and then the others are the input parameters. So it's important to note that. So the other one is the action delegate. So for the action delegate, you use it when you need to perform an action and you don't need any value to be returned. So the syntax is action, and then you have the input parameters, and that's it. So there is no result parameter in action delegate, because it is just for you to take an action, and that's it. No value is expected to be returned. So so if you want, for instance, to take some inputs, and the action you need to take is just to print out those inputs, then you take the inputs and then you just print them, and that's it. You are not returning anything back to the program at all. So the action becomes the ideal, the action delegate becomes the ideal one to do that. And then the final one we're going to look at is the predicate. Delegate. Predicate delegate is used when you need a Boolean result. So it takes only one parameter and now returns a Boolean. So mandatorily, it takes one single parameter, and returns a Boolean. So the predicate is usually used in circumstances where you just want to take a parameter and you conduct some sort of conditional test on that parameter, and which will lead to a true or false kind of outcome. And that true or false outcome is then the result that will be returned. So when you have that kind of situation, then predicate becomes the right delegate for you. So the key, most critical, 3 inbuilt delegates are the func delegate, the action delegate, and the predicate delegate. And what you will see as we move into utilizing lambda expressions in various case business cases or scenarios, then you would find that depending on the scenario, either of them will become suitable. So sometimes, depending on the scenario, func delegates will be the most suitable. Sometimes it will be action. Sometimes it will be predicate, depending on what you are trying to, the scenario that you are trying to deal with. So that concludes the brief overview, the brief introduction, I would say, for delegates. And I think this is just enough to enable us now start applying this knowledge to lambda expressions. So as a final summary, before I move on, you define the delegates like this. You can define your own delegates, and this is the syntax for defining it. Public delegate, then the type that you expect that delegate to return, then the delegate name, then in parentheses the parameters, the input parameters for that delegate. And once you define it like this, you can now define variables of that delegate type, and those variables can now hold methods, named or unnamed, that matches that signature, i.e. it has the same set of the same number of input parameters and the same type, the same number and the same type of input parameters, and then it also has the same result parameter in terms of type. And and once you have that, then you're good to go, because everything, the delegate will, the program will run, because that match is there between the delegates and the variables that we assign to it. So now, with that, let's move forward and actually jump into coding now to see how these things work in actual projects. So right now, I have to jump onto I have to jump onto my C#. Let's do some quick coding. So I'm going to create a new project. That project is going to be a console project, just to make it a lot easy and simple. So it's going to be a console app, and then I will call it Lambda Expression Explained. Okay, if you like, you can put app there. And then you just create it so that we have a brand new project. So I'll delete all these things here. So I'll have a brand new screen. And then I'll start by defining a delegate, like I said. So let's define our first public delegate, and we say maybe it's int, as we saw the other one. And then we can give it a name we like. So because we are trying to do an arithmetic kind of thing, let's just retain our math up delegate, and it is going to have two parameters, int x and int y, yes, and then it will return int. So that's the signature we've created. So now let's define our class. So let's say we want to define a calculator class. So we just say class calculator. Since our example is going to be about our example is going to be about addition and subtraction and all that. So let's name it calculator. So inside this calculator class, then we'll have maybe some methods. So say public method, so it's int, it returns int. The first one is named add, and then it takes integer x and y, but let's change it from x and y so that it doesn't confuse. It's correct syntactically, but so that it doesn't confuse with the x and y that we've discussed, defined for our delegate. So probably we should say integer even I and j. You know, yeah, I and j, and then you do this again. What happened? Okay, well, so I don't know why you did. So let me just do that. Okay. So okay, and then now we say return I plus j, because that's what we want to do actually. We just want to sum up these two integers and return it. And because these are integers, then when you sum the two integers, you are definitely going to get another integer. So the return value matches the return type here, so which is perfect. So now we can put in more methods here, but I want us to do that later. So let's take it one bit by bit so that you can actually understand fully what we are doing. Or even here, we can also change this to A, B, or whatever, but let's just leave it as it is. It's okay. So now, if we then define only the static, the main, because you know in C sharp you need the main to be able to actually get the program to run. The main is where the program starts execution from. So let's define a main for this. So we say static void. Our main usually does not return anything, so and we call it main. And then that. And inside here, that's where we do all our logic. So the first thing is that you want to be able to call this add, and because this add is in a calculator class, you have to instantiate an object from this calculator class, and that object you can call my calc or something. So let's say calculator my calc equals to new calculator, so that it creates an object of type calculator, you know, that you can now work with. So this object then have reference to this add method. So if I then do this, I can then say, let me now define something that is of type mat up. So mat up delegate now. And then you can say, okay, yeah, you can actually say mat addition, okay, is equal to, okay, mat addition, okay, is equal to my calc add. So you are now referencing this particular variable, this particular method, you know, that you've already defined here. So you are assigning that method to this variable, which is of type matUp, and matUp is our delegate here. So you define the mat addition variable of type delegate, and you are assigning the add method to that particular variable. And what this means is that once you finish this assignment, you can now use this mat addition as if it is this add method. So now I can come here and use it anywhere I could have used the add, I can use this now. So I can just say console.write line just to write out what is there. So I can now say math addition, and then I specify the parameters I want to give it. So the parameters, because they are int, so I then give it a value, say maybe 30, 50, and then come here and close the parentheses and put this, and this is perfect. So now it's going to run. So because we are saying math addition, and we know that this math addition is now behaving, because of this assignment here, math addition is now behaving like add. So it's this add that is going to be executed. So you assign this 30 and 50. So this 30 is I here, and this 50 is J here, and it will then return 30 plus 50, which is 8. So if we run this program, we expect to see 8. And let's run it, but let's put a console dot read line, so just to let the thing wait for us to read it. And maybe we can maybe we can actually just include some text to show, to give us the context. So we can say, for instance, addition okay, my add method assigned to delegates function, resulting in addition. So result is then addition. So, and then that's the value that the addition gives you. So so I can actually now take this whole stuff here and then put inside that parenthesis, so that it can give us this context when we run the program. So now we have our program ready, and if we run it, I believe we are going to get the answer 80. So let's run it and see. Add method assigned to delegate function, result is addition. And you see the value is 8. So beautiful. So now if we go back to our class, so we can now, for instance, copy this again and create a negative, a subtraction here, and call this subtraction or subtract. Yeah, call it subtract. So if you want, so this will become a minus. So if you want, we can do j minus I. Let's see how we express this number here. And the right, okay, we express it 30, 50. So the 50 is the higher one. So we can therefore make it j minus I, because j is the second number and I is the first number. So so we can do it like this, and then come here now and just copy this last 3, and then paste it underneath this, and you can now see this math addition is now good. Okay, first of all, we are not going to be repeating this. Since we've done it once, we are not going to be repeating it again. So we take this off. Take this off so that it's just taking the variable, because you've already defined the type. So Now the variable, we now want to change it to, I think we call it subtract instead of add that it was. And then the add method assigned to delegate. So what we then have now is a subtract method assigned to delegate. And as a result, the result should be subtraction. So, and then you just leave it like so. Even though it's called math addition, you now see it's actually assigned a subtract method to it, and the outcome will be a subtraction and not an addition. So, and that's the power of it. So I didn't have to go and change. It's using the same math and addition, and that's probably why maybe the naming convention is important. So you can instead of naming it something that kind of tends to give a specific impression of the sort of function that it's carrying out, you can name it something that is more generic. But let's not bother so much about naming now. Let's just check that it is working. So this time around, it should show us the addition first, which the result should be 80, and then it will show us the subtraction, which the result should be 20, because it should be 50 minus 30. So let's run it and see what happens. So it has shown us the first one, which is 80, which is addition. If we press enter, then it shows us the second one, which is now subtraction, which is definitely 20, because it's 50 minus 30, so 20. So you see, this is beautiful. So again, I can copy the same thing and do, say, multiplication. So do multiplication here. So I say multiply. Okay. And then this will change to multiplication. And it doesn't matter now, because multiplication, it doesn't matter which is where. So whether it's I times j or j times I, it doesn't matter. So we leave it like that. And then we come here, and then we copy and paste and assign now to the method multiply. Okay. And then you now say multiply method is assigned. Assigned to delegate. Function result is multiplication. And therefore the result will be a multiplication result. So now the multiplication will be 30 times 50, which is going to be like 1,500. So if we run this now, you see the first one will be the addition, the second one will be the subtraction, the third one will be the multiplication. We are using the same addition, math addition, and it gives us different results because we are able to assign different methods to it at different times. And that's why it's giving us different results. So if I run this, has given us the first one, addition, has given us the second one, subtraction, has given us the third one, which is multiplication. You see, so this is the power of delegates now, because even at this moment we have actually not done lambda. So at this moment it's just delegates, but it's really bringing out the power of delegates. But in this particular examples, we are assigning named methods. Is important. Named methods to the delegates. So this method has a name. Add, my card.add, which is here. These are named methods that we are assigning at different times to the delegate. Now, the core of lambda is that you are assigning an unnamed or anonymous method to the delegates. So that is the code. So you need to get that. So now, with these three examples, let us now progress and do a lambda expression by now assigning unnamed methods. So things that are not here, not defined as methods here, that will assign, and they will do basically the same thing that the named methods have done. So this, if you like, can now do like say so. Now let's go into the section where we will now be using unnamed or anonymous methods. So here we were using named methods. So all these places we're using named methods. So because we are using named methods, this is not by definition lambda. So for doing the same thing now using unnamed methods, so we now say in the case of lambda, so we now want to define our lambda is our, sorry, not lambda, our delegate is markup, right? Yeah, markup. So markup, so we now give a variable. So maybe, what did we call our variable before? We called it addition or something. What did we call it? Marked addition. So we can actually see, if we try to do math addition, see what is going to happen. So it's not taking it. Okay, I think we can actually still use it like this. So math addition, because it's already defined, so we say math addition equals, then the lambda expression, so you probably say A, comma B, and then so A, B, and then you have the lambda, and then A plus B. Okay, so this is now where we're using the lambda, and you see there's no error, so it has accepted this because this math definition is a delegate, and that delegate matches the signature of what has been done here. It's got two input parameters, so this is the delegate here. So is of type, this math addition is of type markup, and markup is here. So it has two input parameters which are integers, and then one result parameter which is an integer. So, and because that's what we are doing here, two input parameters plus a result that will also be an integer when you sum up these two integer parameters, then that's why this matches. So it takes the signature of what is here and try to compare it with what you have put in, and because it sees that yes, it can work, then it allows that line to be okay. So now if I just do that, in fact, let me just use what we had for addition, because this is addition. So if I copy everything that we had for addition, that's the last two lines for addition from printable point of view, and just paste here, you see that it will work exactly the same way. So because it's gonna, yeah, so it's gonna work exactly the same way. So if I run this, you will see that the addition 80 will start repeating itself. So 80, the first 80 will be this one, which we got by using the named add method, and then the second 80 will be the one we got by using unnamed add method. So if I run this now, so this is the first 80 which we got using the named add method, and then if we press another enter, we now get the 80 that we got using unnamed add method, and this is the second 80. So actually, we probably can just change the context text so that it would let us know that this is unnamed. So here you can say add method assigned to this. So yeah, you can now say add unnamed add. Yeah, unnamed or anonymous. So yeah, I think let's use anonymous add method assigned to delegate function. Yeah, so if I run this, you will see that this is the anonymous add method assigned to delegate function, and result is addition, which is 80. So it's giving us the same result as the first one, but this time now we are now using a proper lambda, and lambda is defining an anonymous function. So it's a function, but it's not named. So it's not a function that we're able to reference the way we're referencing them here, because it's got no name. See, we're referencing add function here, or add method. We're referencing multiply method here. So, but in this particular case, this is not named, so we're not able to reference it that way. So we just defined the unnamed inline. We defined the function inline because it's got no name for us to reference. So that's so we can now repeat this for both minus. So let me do two of them together this time to save time. So both minus and subtraction and what do you call it, and the multiplication. So remember, for subtraction we actually did b minus a. So so you can do b minus a here, and then say anonymous subtract method. Okay, so it's anonymous subtract method, so assigned to delegate function. So result is now subtraction. And then this one will be a multiplication, so we change it to multiplication. And we also say anonymous multiply method. Subtract. So anonymous multiply method assigned to delegate function. Result is multiplication. So now, if you run this, you get the same set of results we got earlier, but this time around using anonymous. So if you run this, so the first addition is 80, subtraction is 20, multiplication is 1500. This is for named methods. So for unnamed, for anonymous, you can say anonymous add 80 for addition, 20 for subtraction, 1500 for multiplication. So you see there is basically no difference between, in terms of results now, between the approach of using the name method and the approach of using the anonymous method. So the anonymous method just describes clearly how lambda works, but the delegate, the function of delegates in both instances is very glaring, and the delegate is a very powerful concept that enables all this. So I think with this we probably will come to the end of this video, and we would probably do another advanced version, advanced video to discuss lambdas, but especially in the context of how it's used with link or in link, in link queries, because Lambda expression is also highly applied within the link statements. So it will be another video we'll create that will be a little bit more advanced than this, that would focus on that aspect and showing how you use Lambda expressions in coming up with queries that would have ordinarily been very, very complex or difficult to even fathom or even express at all. So thank you for listening. I hope you have already subscribed. If you have not, I urge you please to do that. That encouragement enables us to continue to create more videos like this. And more, also important is that after subscription, please like it, share it, comment, tell us your views, tell us things, topics you would like us to help break down in the future. So as you do this, it helps the algorithm to share this video more and let it reach more and more people. And in so doing, at least the greater number of people in the world will benefit from this video. So thank you for watching, and see you in the next video. Bye.